Welcome everyone. My name's Brad.
My name's Hunter.
And today we're going to talk about volcanoes. So we're both grad students in the Department of Earth, Atmosphere and Planetary Science at Purdue University. And we're really excited here to be here today to walk through an activity with you guys. And many of you may have seen a volcano in person, or maybe you've seen a volcano in an image. But volcanoes are holes in the earth where material from beneath the earth rises to the surface, and it's generally warmer than the surrounding material around it, and it erupts at the surface. And these eruptions can be explosive, like the image you see behind me, and they could throw up a lot of ash into the sky, or they could be less eruptive and erupt in the form of flowing rivers, as you can see in this image. So, and volcanoes, they could be active. So they may have erupted recently. Some volcanoes may be what we call dormant, where it may be hundreds of years before they've actually erupted, but they may erupt again in the near future. We also have volcanoes that we've considered extinct, where it's been a really, really, really long time since they've erupted, and they likely won't erupt again, but we don't know for sure. So Hunter's going to talk about what causes volcanoes, and then we're going to go to the activity and actually build some volcanoes and see how geologists are able to understand the different layers of a volcano and learn about its volcanic history.
Yes, and so like Brad said, volcanoes always occur with an upwelling or a rising of material, hotter material, onto the surface. And these happen typically at three critical areas on our Earth. One is on the seafloor, where two different tectonic plates begin to move apart, and this creates room for the hot magma to come to the surface and erupt. Another way that we see volcanoes erupt is through when plates go underneath one another. And so we can see that in another part of this image, and those often cause mountain building, where we see large mountain ranges often associated near the edge of a coast, such as the Cascade Mountain Range on the west coast of the United States and Canada. And another volcanic setting that you could see an eruption is in a hotspot that forms islands such as Hawaii in the Pacific Ocean, and that is an example of an ongoing eruption where we see often new lava come to the surface and build these larger kind of shield-shaped volcanoes. And this is from these really hot areas underneath the crust that heat up the mantle enough that you get a large outpouring of magma on the surface in the form of lava and forms chains of islands.
I have a quick question, Hunter. What are plate tectonics?
Plate tectonics are a driving force in a lot of the geologic processes we see on Earth. And so you can think of a plate as a thin crust on top of the Earth. And the tectonic process is when these plates move, they can move apart, they can move together and rise up, and they can also move underneath one another. And so this is often the driving force with volcanic activity on the Earth.
Cool. So let's actually get into the activity and make volcanoes ourselves. So as Hunter was talking about, volcanoes, they're large mounds on the surface of the Earth, and they're built by various episodes of volcanic eruptions that deposit materials such as lava, ash, and other material associated with that eruption over time builds into the form of a volcano. If you ever go to Hawaii, where we will still see active volcanoes on the Big Island, where you see this mound-like structure, and that's from multiple episodes over millions of years that have built up that mound. So for this activity, we're going to need a few materials that we'll go through. You're going to need some baking soda, which we've poured out a little into a separate cup with a spoon. We're going to need a smaller cup. It could be a small plastic cup like this or a paper cup. We're going to need a measuring cup to measure some of the vinegar, which we'll be using to create our eruptions. And then we'll also need a roll of Scotch tape as well. What else do we need, Hunter?
We need 3 or 4 different colored Play-Dohs, and these will represent the different layers of our eruption as our volcano is built. We will need a marker, which you'll see to draw out borders for these different eruptions, and we will need straw or some type of clear plastic tube so we can see the different layers of the volcanic eruptions.
Cool.
And we need paper towels.
Oh yeah. This is going to be a little bit messy, so don't do this around any valuable electronics or anything, but have a roll of paper towels nearby. So, all right, let's jump into it. So the first is just a quick setup here before we actually make our volcano. I want you to take the cup and some Scotch tape, and you're actually going to tape it to a large white board or a piece of cardboard or whatever, which I forgot to mention, but you'll need a piece of cardboard. That'll keep it a little bit cleaner. And you're going to take the piece of tape and tape the paper cup and attach it to the board, as you can see here. And now we're going to actually jump into making our first volcanic eruption. We'll do about 4 eruptions, and each time we're going to actually use Play-Doh to map out the extent of the eruption. And as you'll see as we create more eruptions, they flow in different areas, and over time they start to build up a mound. So you get a sense of how these volcanoes form over time. So for our first eruption, we're going to take our baking soda. You want to go ahead and do that?
So we'll take a couple of teaspoons of baking soda into the cup.
So 2 teaspoons. And then once we've put the baking soda into the cup, we're going to take our vinegar and we're going to pour out a 1/4 cup of vinegar. So I have this measuring cup here that we'll use. And it's easier to place it on the table on a flat surface and then pour it in just like this. And then once we have our vinegar ready, we'll go ahead and pour the vinegar into the cup with the baking soda, and watch how the vinegar rises to the surface and pours over the edge of the cup. And we could think of the vinegar as erupting lava at the surface.
Paper towel.
Oh yeah.
So this is our first eruption of 4.
Do you have the marker?
Yes.
So before we actually clean it up, we want to mark out the edge of the lava flow. So we're going to take a marker, and it doesn't have to be precise, but it gives you a general sense of how far that lava flowed from the point of eruption. So once we do that, we'll be able to take the paper towels and clean up the vinegar here.
And so once we have the vinegar cleaned up, then we have a traced out line of where our eruption formed. And then we take our first color of Play-Doh, squeeze it out, get out. It's stuck. It's really stuck in there. All right.
That should be enough.
Good chunk of Play-Doh. And so we're going to press that down within the borders of the line, in between that line and the base of the cup.
And you can think of both the vinegar and the Play-Doh representing the actual, well, you could think of the vinegar actually as the lava that erupted from the surface, and we could think about the Play-Doh as representing the cooled lava that actually turns into rock and preserves that past lava flow. So they're both representing the actual lava flow of the eruption, but this Play-Doh allows us to record it over time, whereas the vinegar, it'll be a lot harder to record that activity. So you're going ahead and put the Play-Doh, fit it into your the area you traced. And it doesn't have to be precise.
Okay, there's our first layer.
Okay, so now we're ready for our second eruption. And notice how on the second eruption, the lava may flow in different areas. And after the first eruption may have made changes in the surface of the ground. So there may be different areas that the lava wants to flow. So notice focus on how the lava flows in the second time. And go ahead.
There's a little bit of vinegar still in the cup. And so you can start by just ladling another couple of teaspoons of baking soda in and see how that erupts.
Okay. So we may have to add some more vinegar here.
Yep.
So we'll do a 1/4 cup again. All right. Nice.
Very nice.
So we'll go ahead and record that. So it looks like it flowed a lot out this way. And then up and over here. So I'll go ahead and clean that off while Hunter marks our second eruption. You're going to need a trash can nearby.
Plano. Okay, this is a wide.
Yeah, that was quite the large eruption.
It's a big eruption.
I could get more Play-Doh if we need as well.
Okay. We might need more Play-Doh.
Sure.
But we could also just stretch this out.
Yeah.
To get the extent.
We want it as close to there as possible so we could. Let me get another thing of Play-Doh. If you have more Play-Doh on hand, it'll make it slightly easier so we don't run out.
But also, you can use a little bit less baking soda and a little bit less vinegar if need be to have smaller eruptions.
Good point.
So now we can see how our second eruption is overlying our first eruption. And this is how we start to build those shields like Brad said. And also it's common in volcanic eruptions that often the layers are thickest near where they're erupting from. And as you get further away, they thin out because they just start to cool and can't travel as far.
All right, I think that's pretty good to map our second eruption.
Looks good.
So we'll go ahead and do 2 more eruptions, and then we'll see how the volcano actually looks at depth. So we'll go through the same process again. Maybe we'll use a little bit less vinegar this time. But again, it still gives you the sense of the different lava flows. So put a little vinegar in here, or sorry, baking soda. Go ahead and fill up our vinegar. And then we're ready for our third eruption. And again, look at how the eruption or the lava flows over the surface and may flow in different areas than the previous eruptions.
Nice. Very nice. So we can see that in this eruption, it flowed more to this side. There's a bit over here, but it also flowed more to our left.
And no eruption is the same. You could have different amount of lava that flows out of a single eruption. So the actual amount of material varies based on the eruption. But in general, the style of the eruption, whether it's really explosive and it throws up a lot of ash, or it's not as explosive where you have flowing lava rivers, generally the style of the volcano is very similar with each eruption.
Okay.
Cool. So you could start to see after our third eruption, we have the lava flowed in different areas, where our first eruption was relatively close to the eruption center. Our second eruption was quite a large eruption, and it flowed out towards this way. And our third eruption flowed out onto those first two, the lava from the first two eruptions, and flowed out this way. So let's do one more eruption, and then we'll actually investigate to see what this volcano actually looks like.
Again, adding a bit of baking soda. Got it. Okay. There. Oh, shoot. All right, there's a tip. Don't stick the Play-Doh on early. We have a...
Apparently Play-Doh's sticky, so that's okay. We should have enough Play-Doh.
I think we might need another yellow one to finish.
Another yellow? Sure.
Yep. Thank you. All right. We have built our volcano.
Awesome. So, as geologists, we actually study volcanoes, and what we're able to do is we could look at a record of the different eruptions through time. And one way we do that is to actually take a core of that rock and investigate the different layers at depth. So for that, we're going to use a straw, or you could use something a little bit wider. I think for the purpose of showing on the camera, maybe we'll use the wider tube here.
Sure.
But you could just do this just as easily with the straw.
So our first sample, we are going to take from close to where the eruption was happening. Let's press it in, twist it around. Oh, I'm missing. Come on.
We could also use the spoon to help us.
There's one layer a little bit stuck to the bottom.
Yeah, a little sticky, but it's our first eruption there.
Mm-hmm. And so,
oh, that's cool.
Look at that. If you look, you can see a beautiful layer of our volcanic eruptions. And you can notice as you look at them that they vary in thickness, showing the different quantity that can erupt at a given time in different eruptions, and also that it can be thicker closer in or further out.
Yeah, and you can imagine yourself if you were walking on the surface of this volcano. Right here, we could only see the lava from the last eruption, or I should say the rock that cooled from that lava from the most recent eruption. But if we go down through the surface, we could actually see the previous eruptions that occurred and start to piece together the history of this volcano.
And another thing we would encourage you to do is to take samples from different areas that you have built your volcano from, because these can show and compare how the layers are different or similar based on the sequence of eruptions.
Yeah, you want to go ahead and try and maybe
Sure.
take it from a different area?
You want to do it?
Sure. So maybe we'll take it a little further out and see what that looks like. So how about right here?
Get the spoon again. Just a little bit of green.
So if you notice here, we were a bit further out from the eruption center, but we haven't sampled as many layers. For example, you don't see our yellow layer in here, but we were able to sample the orange layer, which was our, I believe, second eruption, and then a little bit of our first eruption. So we actually don't see the most recent eruption and then our third eruption, which is shown by blue.
Yes.
So these are certain things we can do to understand the history of a volcano. And one last point, if you could see the structure of a volcano, you could see that our lava flowed really far out from the center of the eruption. There are volcanoes that do this. For example, volcanoes in Hawaii, they may be really broad and widespread. Other volcanoes may have lava that's a lot stickier and doesn't flow as easily, so it builds these large cones. So if you see different images of volcanoes, they come in very different styles and shapes. But they all relate to this warm material rising to the surface and erupting into the atmosphere and on the surface.
If you want to look up two good examples of that, like Brad said, Hawaii for a more spread out volcano, and Mount St. Helens is a very famous example of a more built up, stickier formed volcano that erupted very explosively.
Okay. One last question before we say our goodbyes. Do volcanoes only happen on Earth?
That's a great question.
Yeah. Can you answer that for me, Hunter?
Absolutely. Volcanoes are an extremely important process, not only on Earth, but in the entire solar system. And we see examples of it not only on the planets in the inner solar system and outer, but also on the moons. So implying that this is a process all over shaping different bodies in our solar system.
Yeah, so it's an incredibly important process that we see throughout the solar system, both on our, as Hunter said, on our rocky planets on the inner solar system and some of the moons of the outer solar system. For example, this image here, this is Io, which is a moon of Jupiter, and it's one of the most volcanically active bodies, either planet or moon, in the entire solar system. And you could even see in this image a plume of that volcano that we've been able to see from space. So it's an incredibly important process that not only happens here on Earth, but other places in our solar system that we can observe with different spacecraft. So with that, we hope you enjoy this activity, we thank you for joining us today. And thanks again, and hope to see you next time. Take care.